Now it is asked in GATE 2007, they are asking about what is the waiting time of process P2 using SRTF. So even though they are asking for only one process, let's do for all the processes. So first thing is, you know that arrival time has to start from 0, fine, and then only one process available as of now, so which is P1, fine. Now don't try to stop process P1 for every 1 unit. See when the next process is going to be available. So if you start P1 at 0, the next process is going to be available at 15. Therefore it is better that you run till 15, then only you check that whether the next one is having remaining shortest burst time or not. So don't stop on waiting for 0, 1 and then 2, 1, 3 like that. Here you need not wait for that, because it is always better that you see when the next process is going to arrive. Next process is going to arrive at 15, therefore you run it till 15 and then maybe you can stop and check, right? So next process is arriving at 15. Now by that time I have executed this for 15 units, therefore what is the remaining time for P1? 5. And now compare it. Now I have two processes available, one is P1, other is P2, and then both the burst times required are one is 5 and other is 25. Therefore we are going to continue with P1. P1 it requires 5 more, therefore 20, and P1 is over now, right? Now what is the time? 20, and now P1 is over, so only one more process is available, isn't it? By the time 20, only these two processes are available, one is finished, therefore we have to schedule the next one, because we have only one available now, right? Now it is going to be P2. So watch it. So P2 is going to start at 20, then how long should I run it? Till the next one becomes available, right? So when is the next one available? At 30. So till 30 you run it. Therefore how much time did you run P2? For 10 units, 20 to 30, right? So you decrement it by 10, which is nothing but 15 here, right? And now you check. Now I have P1 and P2, P3 all are available, but P1 is already finished, therefore I have choice between these two, P2 and P3. So P2 is saying that it has 15 units of time remaining, and P3 is saying that it has 10 units of time, therefore you better run P3, right? Now if I run P3, then what happens is P3 requires only 10 units of time. The next one is arriving at 45, therefore if I run till 45 it is going to be 15 units of time, but then P3 is P3 requires only 10 units of time, therefore I am running till 40. Are you understanding the logic? If the process requires less time, I am just running it to completion, otherwise I am just waiting at the arrival time of the next process, therefore I can stop there and decide whether the next process is having less burst time or not. In this case, the next process after P3 is arriving at 45, but then I cannot run P3 for 45 till 45, because it requires only 10. If I go for 45, then I might have to wait for 5, therefore I'll be running till 40. And now I decide which one to schedule. Now what are the various processes available? Only 3, P1, P2 and P3. They have arrived below 40, they have arrival times below 40, and already P1 is over and now P3 is over. So only one thing I have is, out of no choice, I have to run P2, isn't it? Therefore I am going to run P2 only. Fine. How long are you going to run P2? P2 requires 15 units of burst time, right? And now P2 requires 15 units of burst time, but then the next one is going to be available at 45. Therefore I am going to run it till 45, which means 5 units. Therefore the remaining time for P2 is 10, and now I stop and compare. So I have, by this time all are available. P1 is over, P3 is over, now only these two are remaining, and now which one should I choose? P2 itself. Therefore I'll continue using running P2, right? If I run P2, and how much time is remaining for that? 10, therefore 55. So 55 is the completion time for P2, right? And what about next one? P3, P4, right? That is only remaining, therefore P4. How much time does it need? 15. So if I go with 15, it is going to be 70. Got it? So that is how we could finish it off. So one thing you should observe here is, whenever you choose one process to run it, either you go till the completion or you stop at the arrival time of the next process, and at that point you can stop and see whether the next process requires whether the next process is having less BT, that burst time. In case if it is having less BT, schedule it, otherwise continue with the present process and again run it till the arrival time of the next process. So don't stop it for every 1 unit, otherwise it is going to become very big. Got it? Just be careful there. Fine, that is all. It should be intuitive for you. Now let's see the completion time of all the processes. Even though they are asking for only P2, you can only write for P2 and then you can find it out, but okay, I want to do everything, or you can just choose it like P2. Let's solve it P2 first. Now P2's completion time is 55, right? And therefore what is the turnaround time of P2? Turnaround time of P2 is completion time minus arrival time, which is nothing but 40, right? And what is the waiting time then? Waiting time is turnaround time minus burst time. Turnaround time is 40 and the burst time is 25, therefore waiting time is 15. This is the answer. Got it? Or if you want to fill it up, you can fill it up. That is up to you. Anyway, just remember that whenever we have a long gap between the arrival times, don't stop the process for every unit. Just stop the process whenever the next process has arrived. Then you just see what you want to do, whether you want to continue with this one or change it, right? Fine. So that is how this one could be answered. Interesting question, right?